day, everyone. We had the class last time, and the class was on statistics. We talked majorly on the ungroup data, and I was able to show us that ungroup data can be a raw data in which data are collected individually from different samples, and also this data can also be classified into or presented in a frequency table. But the fact that it's presented in the frequency table does not necessarily mean it's a group data. So we calculated the mean, the median, the mode, which we refer to as the measures of central tendency or measures of location, and also we're able to calculate the variance, standard deviation, the interquartile range, semi-interquartile range, which are classified under measures of dispersion. Today we shall be examining the group data. What are group data? Group data is a kind of data where we have to collect our samples in groups or in classes. What do I mean by that? Instead of saying this person is 5 years, the other person is 10, the other person is 15, now we decide to collect our data in classes. Okay, let students who are between the ages 1 and 5 stay in a class. Then 6 to 10 in another class. 11 to this in another class. So those classes are going to be recorded. Then our frequency will be classified or assigned to each of them, each classes. So today we'll examine how to calculate the mean under group data, the median, the mode, the quartiles too, and how do we even present this data in the frequency table. We have a question here, and these are a set of masses of students in the class. So we take the masses in kilogram. Each values are in kilogram. We are to present this data using the frequency distribution. And how do we go about this? To classify them into groups. Don't forget, we are talking about group data. Now, we need to predetermine the number of students that we want to be in a particular class. Or let me say the classes, number of classes we want. If in the question we're given the class intervals, I'm going to explain that later, we just need to move on and start classifying our data. But in this case, if it is not stated, we need to determine that and find out. But how do we do that to know the number of classes that we are going to have, or number of groups? This is what we do. Now we have the interval. This one tells us of how long, how wide we want our group to be, each group. So the range from last class, I was able to show us that range is the highest value minus the lowest value. So from the data here, we find out that 949 is the highest value and 10 is the lowest. So if we wish to classify this data into 10 groups, then the interval becomes 49 minus 10 divided by 10. This gives us 39 divided by 10. So we have 3.9, and this is approximately 4. That is, each class should have a wideness of 4. The interval should be 4. And our class interval becomes 4 for each group. I'm going to show us how to express that now. Alright. Now we have the data classified into classes. I call this CI class interval. Now this tells us that since we have already obtained 4 as the class interval, or the number of wideness, or the wideness of the class. We have 10, 11, 12, 13. That's 4. So in this class, the class interval is 4. For this is also 4, up to 46 to 49. So what this means is that those students whose masses are between 10 and 13 will be classified here. The students between 14 and 17 kilogram will be in this class, just like that. Now, instead of taking it for one student each, just like we did for on group data, now we have classified them. Then whatever frequency we have will belong to this class. So we have 10, between 10 and 13. We start counting from here. It is only 10 that we have. If you look at this data very well, we have only 10, between 10 and 13, and that's how I got 1. The tally represents a symbol of 1 here, which is 1, then we write 1 here. Then between 14 and 17, we have only 1, 2. Between 14 and 17, we have only one number 2, which is 17. And 18 to 21, the time we study this, we move on, we have 20, and we also have 20 again. So 20 is between 18 and 21, and that's how I got 2. So we keep going, we take between 22 and 25, come to this place, check for numbers between 22 and 25. Or let me start from 20, because 22 is included too. 22 is also included. So by the time we count, we find out that there are 4 numbers between 22 and 25. So if you check from here, we don't have any here. 22 and 25, this is 25, 1. We go on. Two, this is 23. 3. You should have 4.
This 24.
Yes, 24 also.
Last line.
Yes, sir. So we have 4 of them. 1, 2, 3, 4. And that's how I got my 4. The same thing we are going to repeat for all the numbers. Now we have here 46 to 49. If we count and check the numbers here, realize that they are 6. That's how I got my 6. So from here, we can now start to calculate either the measures of central tendency, measures of dispersion, or different questions can be asked from this kind of data. We could even be asked to find the cumulative frequency, the histogram, and other graphical illustrations of data. And we shall examine that in the future. So, (10 to 13) is called the class interval. This 14 to 17 and so on, the class interval. (10 and 13). Just for each of them too, but I'm picking the first one to explain. Each of them also represents what I want to express here. 10 and 13 is the class limit. So for this class, the limit, we call 10 the lower class limit, and 13 the upper class limit. We also have the class width. Class width, just like we got the class interval, class width is, we can take 10, 14 minus 10, 18 minus 14, 22 minus 18, 26 minus 22, it all gives us 4 each. So the class width is 4. Class width equals to 4. There is also what we call the class boundary, but when I get there, I'm going to explain. we can also get the class width from the class boundary. From the data, we want to calculate the mean, the median, and the mode. Just like in the last class, where we were able to present data in a frequency distribution like this, but not group data. We remember that mean, which is x bar, is given by summation fx divided by summation f. So if we have this, we need to think of how to obtain the mean from this data. Since the class interval is not one single data that we can refer to as our x. So what do? We need to obtain a class mark, and that is why I created this column for class mark, and I have referred to my class mark as x. So when we have grouped data and we want to calculate the mean, we need to get the class mark. And how do we obtain the class mark? The lower class limit plus the upper class limit divided by 2. What do I mean? For me to get 11.5, I added 10 plus 13 divided by 2. And I obtained 23 divided by 2. That is 11.5. So for the second class mark, 14 plus 17 divided by 2 gives us 15.5. 18 plus 21 divided by 2 gives us 19.5. Up to this, 46 plus 49 divided by 2, which is 47.5. Now, we have been able to get the fx, which is now the frequency multiplied by class mark x. Fx, frequency multiplied by the class mark, which is x. Please don't forget that x represents the mid value, which is the class mark, instead of the class interval. So we have 1 times 11.5, that gives us 11.5. 1 times 15.5 also gives us 15.5. 2 multiplied by 19.5 gives us 39.0. Goes on like that. 4 times 23.5 gives us 94.0. I hope that's clear. Up to 6 times 47.5, which gives us 285.0. Now, back to the formula for mean. Summation fx divided by summation f. And I remember I was able to explain that this symbol summation means the addition of all the data in that category. So fx is the addition of 11.5 plus 15.5 plus 39.0, 94.0, 82.5 up to 285.0. If you add all this together, we have 1783. Then our summation f, which is the addition of the frequency, is 1 plus 1 plus 2 plus 4 plus 3 up to plus 6, and we have 50. So if we divide this by this, we have 35.7. So that's the mean. For us to obtain the median, I remember that median, like I said in the last class, stands in the category of second quartile. Second quartile Q2. But now, this is a group data, unlike the other one which was ungrouped data. the method of obtaining the median in this case is different from the method of obtaining the median, the one we did the last time. So Q2, which is the median, is obtained like this. L plus N over 2 minus CFB. I'll explain what every symbol represents. Divided by F multiplied by W. This formula is what we are going to use to obtain the median under grouped data. L stands for lower class boundary. Of the median class. N is summation F, the total number of students, since we are dealing with students here. CFB represents cumulative frequency before the median class. F stands for frequency of the median class. Well, finally, W is the class width. So now that we have written the formula and explained what each of them stands for, like I said, L is the lower class boundary of the median class. Now, what is the class boundary? Don't forget the other time I mentioned the class limit. That is, 10 is the class limit for this class, lower class limit, and 13 is the upper class limit. 14 is the lower class limit here, 17 is the lower class limit here. But the class boundary, which is this, I need this column. Now, I need to quickly emphasize this point. It is the formula, or let me say what I want to do, what I'm planning to calculate, that determines the length of my table. If the question only emphasizes that I find the median, I do not need to get the class mark. I don't need to waste my time on that to obtain the class mark, let alone fx, because it is only in mean that I need summation fx, and there is nothing like that in this formula. So I'll just go straight to the cumulative frequency, the class boundary, and attach it to other ones. So here, lower class boundary of the median class. So that means we have to first obtain the median class. If we do not know the class, we can't proceed. So how do we know the median class? Recall that I said the other time that median is obtained like this, 2n over 4, which is Q2. Q1 is n over 4, the quarter, and Q3 is 3n divided by 4. But in this case now, if I divide 2 here 1 and 2 in 4, 2, I have 1n, which is n actually, divided by 2. So n over 2 is very obvious in my formula. And this is n over 2. So this will help me to locate the median class. What is n? I said n is summation f, the addition of all the frequencies. If I add all the frequencies together, it gives me n, which is summation f. And from the question, if I add this together, I have 50. So my n is equal to 50. So from here now, 50 divided by 2 will give me 25. Now I come to the frequency. We can use the frequency, we can also use the cumulative frequency, either of the two. 25, if I start counting from here, 1 plus 1, 2, 2 plus 4, 2 plus 2 rather, 4, 4 plus 2, 8, and that is what cumulative frequency already represents. Cumulative from the word accumulate, to add together or to combine. So the frequency has been accumulated here. So 1, I repeat the 1 here. So this 1 plus 1 here gives me 2. I'm trying to explain how I obtained my cumulative frequencies. I repeated the first one here. Whatever number we have here, just repeat it here first. Then that number plus this, that's 2. That's how I obtained 2. 2 plus 2, that is 4. 4 plus 4 gives us 8. 8 plus 3, 11. 11 plus 7, 18. 18 plus 8, 26. 26 plus 8, 34. 34 plus 10, 44. And 44 plus 6, 50. So you should note that the last number on the cumulative frequency is also equal to summation f. So the addition of all the frequencies must also be the last number in the cumulative frequency, since we actually added them together. So this helps us to even know that you have done the right thing. Summation f here must be equal to the last number on the cumulative frequency. I hope that is very clear. So I have gotten 25 here. I need to trace where 25 falls. Is either I start counting and see where I'm going to end up. This is 18. Then the 25th number is actually here. It's going to fall inside this place. So 26, I'm going to trace it down. Trace it back to the class. From 26 here, I'll trace it back to the class. Therefore, the median class is 34 to 37. The median class from here, tracing it down back to the class interval, we have it falling 34 to 37. So the median class is this. The moment we obtain the median class, it is very easy to get other answers. So L, which is the lower class boundary of the median class, now tells me to go back to the median class and get the lower class boundary. And this is the class boundary. So I need now to explain how I obtained my class boundary. The class boundary is very simple to calculate. What we just have to do is to come to the first part, subtract 0.5 from the lower class limit of the first class. So 10 minus 0.5 gives me 9.5. And the 0.5 that I took out of this, I'll add it back to this, to 13. And that's how I got 13.5. I mean 13 plus 0.5. This will give us 5 point. So this is 13.5. That's how I got this. So the same thing happens. And that's how we keep going. 14 minus 0.5, 13.5. To add it to the next one, 17.5. So if you look at it very well, you see that whatever is the upper class boundary of the first class will be the lower class boundary of the second class. It's 13.5 to 17.5. So that means the next class starts from 17.5 to 21.5. So this starts with 21.5, then to 25.5. Then we keep going up to 45.5 to 49.5. Since this is 46, if I remove 0.5 from 46, I have 45.5. I add the 0.5 to 49, it gets 49.5. So that gives us the class boundary. Now, we were able to get the median class as 34 to 37. So what is the lower class boundary of the median class? From here down to the class boundary, the lower class boundary of the median class is 33.5. So L equals to 33.5. N over 2, I've already gotten that, 25. Then CFB, which is the cumulative frequency before the median class. Cumulative frequency before the median class. This is the median class. This is its cumulative frequency. Then the one before the median class. Again, this is the median class. So that means the cumulative frequency of the median class is 26. What about the one before it? Is 18. So CFB is the cumulative frequency before the median class, and that is 18. And that's how we obtain this 18. Then we proceed to F. F implies the frequency of the median class. We have located the class 34 to 37. So what is the frequency of that class? 8. The frequency of the median class is 8. F equals to 8. Then width, the class width, just like I've said earlier, you can obtain it by taking 10 out of 14. That's 14 minus 10. Or counting here, 10, 11, 12, 13, which is 4. Please don't make the mistake of subtracting 10 from 13. Most students make that mistake and say the class width is 13 minus 10. No. 10 is also part of the class. So we have to count it. 10, 11, 12, 13. And that is 4. That is how we obtain the class width as 4. Also, if you do 13.5 minus 9.5, it gives us 4. 37.5 minus 33.5, it gives us 4, since that is our class. So W equals 4. The next thing to do is to now substitute these values into the formula and calculate. Alright, I have a very good question. And the question is, how did I move from the class interval to the class boundary? And where did I get the 0.5 that I was adding, I was subtracting from the data? Number one, the class interval is telling us the wideness of the class, of each class, and we can see that each class has the same interval. Then the class boundary too, we are trying to obtain a boundary, a kind of the extreme on this first side and the total extreme on the other side. Number one, because we're also dealing with a continuous data. What do I mean by continuous data? Data where we are considering the decimal points too, and not just the discrete 1, 2, 3, 4, 5, 6. So the 0.5, just out of 1, if I divide 1 by 2, it gives me 0.5, and at least that's the average. So I took the 0.5 from this part and I added it to the other part. It's not like I took the 0.5 out and it's not reflecting here again. So 10 minus 0.5 gave me 9.5. And the other 0.5 added it to the other side, just to create a little other boundary for this, create it to the other side, make it a little wider, and make this one also a little wider to the other extreme. This is the lower one, widen it a little bit. This is the higher one, extend down a little bit. So that's why I just took out 0. Of course, that is the general way of handling this. We must take out the 0.5 from this and add it to the next one. Now, we have to fix the values into the formula. This formula is important that we try to write it over and over until we can master it. It's not add L plus, upon a big bracket, n over 2 minus CFB divided by FW. And now that we know what each of them stands for, the lower class limit of the median class, lower class boundary of the median class is 33.5. And that is how I got 33.5. So I fixed 33.5 for L plus n over 2, which is 50 divided by 2. That's 25. And that gives us 25 minus cumulative frequency before the median class, 18. And that's how I got my 18 here. Divided by 8, which is the frequency of the median class. Then W, the class weight, is 4. So the rest is just simplification. 25 minus 18, 7. So if I divide 4 here 1, 4 in 8, 2. So 7 over 2 will give me 3.5. Then 35.5 plus 3.5 gives us 37. I have a very good question here, and that is, how do I link my 37, the answer here, to the data? I have found out that my median, which is Q2 also, is 37. So median, from the question we have to calculate the mean, the median, and the mode. So median here is 37. And how do I link it here? Check the median class, 34 to 37. So what this is simply telling us is that our median 37 can be found in this class, truly. And apart from that, imagine that I'm looking for a student in a particular school. I don't know where the student is. And I just got to the gate of the school and I'm looking for this student. He's tall, he's huge, he has a black hair. I just described that. And the gate man just, check SS3 class. Now, this gate man has actually narrowed down my stress, or he has reduced my stress. Instead of going to GS1 and checking if the student is there, going to GS2 and checking if the student is there, going to GS3 one by one, he had already told me that this is the class. Go to SS3 directly, so I don't have to be wasting my time. Despite the fact that I have known the class, does not mean I still know or I've still found the student. So the class, this one helped us to obtain the class. Like we know that, okay, 34 to 37 is a class where the median lies. It's only telling us that this is the class where I can find the median. It does not mean that this is actually the median. So I'm looking for the exact value that is the median. And now I've obtained 37 as the median. That is, now after getting to the class, this is the student. So that the class only tells us where the student lies. And I'm going to find that student inside that class. So I'm looking for the median. This is the student I'm looking for. I'm looking for the median. Then I was able to know the class where the median lies. And now using this methodology, using this formula, I was able to locate that exact student, the median. And if you look at it, if you calculate and your value is not within this interval, then you are wrong. So you make sure that after locating the class, the value you are obtaining is still lying inside the class. So if I obtain 38, then I've already made a mistake because it's outside the class. So we'll move on to the last question, which is to obtain the mode from this set of data. To obtain the mode also, we need to use this formula. So I will tell us what each each symbol represents too. L, just like I said earlier, the other L represented lower class boundary of the median class. So now that I'm trying to get the mode, so this would be the what? The lower class boundary of the modal class. Whatever I'm trying to get, anywhere we see the L represents the lower class boundary of that class where that which we are looking for belongs. And I remember that in the last class, I was able to tell us that mode represents the number with the highest frequency. And we need to also locate that class before we can proceed. Before we move on, we must locate the class. That's the first thing. So, which class does the mode lies? Which one has the highest frequency? 1, 2, this. We realize that 10 is the highest frequency there. So, trace it back to the class. The modal class is 42 to 45. So, modal class then we can proceed. L, lower class boundary of the modal class. In some textbooks, they put the M here, but I don't want to confuse us because if I do for median 2, I will put LM. M here too for mode, it still be LM. To avoid confusion, just take the L as the lower class boundary of whatever class we are trying to find out. Delta 1 is the frequency of the modal class minus, please, I'm using this as minus frequency before the modal class. Delta 2 is frequency of the modal class minus frequency after. W represents class width. So from the data, we realize that L is equal to, since this is the class of the mode, that is the modal class, the lower class boundary of the modal class is 41.5 from here. Delta 1, I said it is the frequency of the modal class minus frequency before the modal class. Now, this is the frequency of the modal class, 10. This is the class, and this is 10, which is the frequency of the modal class. So the frequency before it is 8. 10 minus 8, and that is 2. Delta 2 is the frequency of the modal class minus frequency after the modal class, and that is 10 minus 6. Don't forget, this is the frequency column. The frequency column, 10 minus 6, and that is 4. 10 minus 6, 4. Hence, you say that the mode is equal to 41.5 plus 2 divided by 2 plus 4 multiplied by 4. And this gives us 41.5 plus 2 times 4 here is 8 over 6. So 1.5 plus 1.63 in 4 is 1, then in 10 that's 3, just keeps going. And we have 42.833 approximately. Now I have a question, and the question is there another way to simplify this expression 45 plus this bracket, which is 2 divided by 2 plus 4, close the bracket, multiply by 4? Yes, there is another way to simplify that. And we can go like this: 41.5 plus, deal with this bracket and get the whole number, which is 2 divided by 6 multiplied by 4 again. If I simplify 2 over 6, I still get 41.5 plus 1 over 3 times 4, because 2 here is 1 and 2 in 6 is 3. Now I need to emphasize that this 1 over 3 is not two numbers. We have 1 over 3, and that is a single number too. Just like if I have 2 in the bracket times 4. I could have also expressed this as 4 over 2 times 4. So if I say 4 over 2 times 4, which is also 2 here, I don't have to now multiply 4 times this and use the 4 to multiply 2 again. So this entity, 1 over 3, is a single number, and that gives us 41.5 plus 4 times 1, 4 over 3. We don't have to multiply 4 times 3 again, since we have multiplied 4 by 1, which is part of the whole number, 1 over 3. So 4 over 3, just like we obtained here, is still 1.333. So that's 41.5 plus 1.333, which is equals to 42.833, and approximately we have 42.8 as the mode. Now I have to show us where this mode is in the data set. Don't forget that the mode is 42.8. And like I said, 42.8 is that exact value that represents the mode of the total set of data. This is the modal class, 42 to 45. And this is 10, the frequency that shows us that this is the modal class. 10 is the highest frequency of all of this. So the class, we have 42 to 45. Definitely our mode must lie inside this class. So if we have 42.8 here as our mode, then it still lies, 42.8 is inside this class. And that is the exact mode. 42.8 kilogram is the modal value, that is the one with the highest frequency that occurs most in the set of data we have. We have obtained the mean, the median, and the mode of the data set that was presented at the beginning. So we could also go further and be asked to calculate the interquartile range or the semi-interquartile range, just like we calculated in the last class. Interquartile range, I'm using IR to represent interquartile range. So we have obtained the mean, median, and mode for this group of data. If the question now goes further, that we should calculate the interquartile range and the semi-interquartile range. In the last class we had about ungroup data, where we calculated the interquartile range. I said I interquartile range as Q3 minus Q1. So definitely we need to obtain the Q3 and also the Q1. Don't forget that semi-interquartile range also is Q3 minus Q1 divided by 2. So just like this is also a group data. This is a group data. The one we had last was on group data. It was easy for us to locate the n over 4th position, try to trace it on the data, and we got that value. That is the Q3 or the Q1. But here that we have intervals, that we have classified the data into groups. Just like I said earlier, the group is only going to give us a particular class where the real value lies. So we need a bigger, or let me say a more beautiful formula to find out that information. So if I want to calculate the Q1 here, I use this formula. Q1 equals to L plus, open the bracket, n over 4 minus the cumulative frequency before divided by frequency of that class, the Q1 class. Close the bracket, multiply by class width. So if we connect the median, the quartile, even the mode with this, realize that the formulas actually look alike. And the only difference is actually A. For the median, we had n over 2. For the Q1, we have n over 4. For this Q3, we have 3n over 4. So, for me, if I were a student to write this exam, I just master this formula and just know that when I'm doing the Q1, this place I use n over 4. When I'm trying to get the Q2, which is the median, I use n over 2. And when I'm trying to obtain the Q3, which is the third quartile, I use 3n over 4. And that is the only different thing in the formula. So, L is now the lower class boundary of the first quartile class, the Q1 class. N over 4, since we are dealing with quartile, we have to divide it by 4, which is the summation F. And that's 50 divided by 4. Cumulative frequency before, that is cumulative frequency before that class. So if I do 50 over 4, that gives me 12.5. So 12.5, I go to the data, locate the class, and move on with my calculation. N over 4 is talking about the position, the n over 4th position, 50 over 4, 12.5. So the 12.5th position, where can I find that? If I add the frequency, just like I said before, I found out that this is 11, 1 plus 1, 2, 2 plus 4, 2 plus 2, 4, 4 plus 4, 8, which is 8 here on the cumulative frequency. But it's easier to use the cumulative frequency. It's easier to use the cumulative frequency to locate so that it won't be confusing. So after the frequency, obtain another column for cumulative frequency. So since this is the subsequent additions that I want to be doing one by one manually here, I've already done it here. So 12.5, where would that be? I started counting. This is 8. I counted. This is 11. So the 12th value will be here. 12.5 value will also be here. So definitely this place is where the first quartile class lies. And that is going to give us 30 to 33. 30 to 33. So this is the class of the Q1. L, the lower class boundary of the Q1, is 29.5. If I subtract 0.5 from 30, or if you go to the class boundary, you see the lower class boundary of that class. So that is 29.5 plus n over 4, that's already 12.5, minus the cumulative frequency before that class. Don't forget that this is my class. This is the class, and I trace it down to the cumulative frequency. So what is the cumulative frequency before 11? Before this class, that's 11. And that is where I obtained my 11. Divided by the frequency. I hope that is clear. The frequency of the first quartile class, the Q1 class. What is the frequency? You move on to this part. This is my class. Trace it down to the frequency. So what is the frequency of that class? The frequency is 7. That's how I got 7. Close the bracket, multiply by the class width, 4. 10, 11, 12, 13. Or 14 minus 10. That's also class width. For every class, that's what you get. 14 minus 10 is 4. 18 minus 14 is 4. 22 minus 18 is 4. Just like that. If I also come to this class, 33.5 minus 29.5 is also 4. So our class width is 4. Then the rest, just simplify the expression. The moment we have substituted, the next thing to do is just to simplify our substitution and get an answer. So 29.5 plus 12, this is in the bracket, 12.5 minus 11 gives me 1.5. Then I repeated my 7, close the bracket, times 4. 4 times 1.5 is 6. So that's how I got the 6 here. I've used the 4 to multiply the numerator. Don't forget that this 1.5 over 7 is a single number. And I multiply 4 by 1.5, which is the numerator alone. I don't have to multiply 4 by 7 again. So this gives me 6 divided by 7. Then 6 over 7 will give me 0.8571. 0.8571. So add it together with this. 29.5 plus 0.8571. We have 30.36. So if I come back to the class, the first quartile class, 30 to 33, you realize that our first quartile actually is exactly lying inside the class. So for Q3 also, the same thing. We move on to this part. Now, L is the lower class boundary of the Q3 class. I mean the third quartile class. 3/4, that's just it. Third quarter, 3/4 of the total number, the 3/4 of the total data that we have. So n is 50, remember? 3 times n, that is 3 times 50, will give me 150. So 3n over 4 is actually 3 times 50 divided by 4, which is 150 over 4. So if I divide 150 by 4, I'm going to obtain 37.5. So the whole of this is 37.5 after simplifying it here. Minus cumulative frequency before. So 37.5 helps me to locate the class. That is, this is the 37.5th position. The position of this Q3 is going to be around here, 37.5th position. So we come back here again. I said the cumulative frequency is easier and helps us faster to locate that class. Instead of counting or adding together, we might even make a mistake. But since we have done that already here, we'll be able to locate it easily. So where can we add it up to get 37.5? This is 4, 8, 11, 18, 26. This is 34. So the data ends at 34. We have to continue here. So that means the 35th, 36th, 37th, 38th, 39th, 40th, 41, 42, 43, 44th lies here. So definitely 37.5 is within this range. So by the time we trace it down, we realize that the class for the Q3 is 42 to 45. It's very important to locate the class first before looking for that thing inside the class. 42 to 45. And we have this. So the cumulative frequency before that class, the cumulative frequency before is 34. That is how I obtained my 34. Then let's move on to the numerator, which is F, and that's the frequency of the third quartile class, the Q3, the frequency of that class. Remember that this is the class, so trace it to the column where I want us to consider this example on the board, just to explain further on how to present our frequency table. The question says the following table shows the frequency distribution of the masses of 100 men to the nearest kilogram. So if the question is already presented like this, they have already arranged it in the table for us. So our own is just to turn this the other way around. You know, this is going horizontally. So we just turn it vertically like this. Then our mark, the mass in kg here becomes class interval. Then we put the tally. Then the frequency, which is this. So our own is just to repeat what we have in the question. Then we can move on. Instead of trying to find out what the class interval would be, the one we did earlier where we were doing 49 minus 10 divided by 10. You don't have to do this again, since the question has already been classified into classes. Some questions too, they might also tell us or give us the data set just like we have it earlier. Then tell us that use the class interval 55 to 59, 60 to 64, up to 100 to 104. So it is now left to us to understand that, okay, what is the interval here? 55, 56, 57, 58, 59. So that's adding 5 to each of them. So that means for me to know the next one, I'll just do 65 to add what's it called to it, because this is 55, then plus 4 gives me 59. So if I do 65, 66, 67, 68, 69, so this will be 269. So that will that will cover what is actually here, because this dot means that there are other sets of classes within this range, and this is the last one. So it might be presented in this way. What we just have to do is to use this understanding to get the next one and the next one until we get to this point. So the moment we have been able to do this, every other thing, whatever we are asked to calculate, either median or the quartile, Q1, Q2, Q3, or the mode, follows the same process that we have used earlier.